My name is Siddharth Birmal. Now I am explaining you atmospheric circulation. In atmospheric circulation, first we see global heat budget. Excess at the equator, deficit at the poles. Therefore, all air and ocean current transport heat polewards.
Now we assume a non-rotating Earth. Convection cell. This is a term used to describe the process of warm air rising, traveling laterally, cooling and sinking and returning to the source region along the surface. If there was no land no on Earth, we would have two big convection cells, one in each hemisphere. Remember, air moves from hot to cold and high to low pressure. Convection cell would operate from the equator to the poles, with air flowing upward at the equator, cooling at the top of the troposphere and descending when cool at the poles.
The three cells. Unfortunately, it is not that simple. The Earth is split into three cells in each hemisphere. The first cell is known as Hartley cell, which is in between 0 to 30 degree latitude, and second cell is known as Ferrel cell, which is in between 30 degree to 60 degree latitude, and last cell is known as polar cell, which is in between 60 degree to 90 degree latitude.
Now we discuss about Coriolis. This is the effect of Earth spinning. It is affects all large bodies of liquid or gas, that is water and air. Remember, the Earth spins anticlockwise if you were looking down on the North Pole as in from west to east. Therefore, along the equator, major currents flows from east to west. Hartley says, the helial circulation patterns of which the trade wind form the surface expression, the north-south component of the helial circulation is known as the Hartley circulation. The two Hartley cells can be seen either side of the equator. This is the diagram of general global circulation of atmosphere. Global circulation. Wind circulates in each hemisphere in the three distinct cells, which helps transport energy and heat from the equator to the poles. The winds are driven by the energy from the sun at the surface as warm air rises and cold air sinks. The circulation cell closest to the equator is called Hartley cell.
The ITCZ. It is the junction near the equator where the two Hartley cell land-based currents meets. This is stand for the Intratropical Converging Zone. Its position change with regards to the season. Changing conditions over continent and ocean in a monsoon climate. Northern winter. Dry cooled air subsides over the continent, which is a region of high surface pressure. Wind blow off the continent, picking up moisture from much warmer ocean, and eventually moist air rises at the intratropical converging zone, causing abundant rain. Northern summer. Land is now much warmer than ocean, so the region of low surface pressure corresponding to the ITCZ and its zone of rain has moved northward towards the interior of the continent. Thank you.